Today's review, we're going over 5.3 and 5.4. 5.3 is exponential growth and decay. We want to separate a growth rate from a growth factor. Growth rate is how much we're growing by. So for instance, we may be growing by 5%. And so the growth factor is what we put into the equation. So we have to have 100% to keep what we have plus the 5% that we're growing. So our growth factor is always going to be 1 plus the rate of growth. So if we have a growth rate of 5%, our growth factor, what we put into the equation, is 1.05. Now we can also have decay. So decay rate is what are we decaying by? So we could be losing 5% of something. The decay factor is what goes into the equation. And the decay factor is always 1 minus the rate of growth. If we're losing 5%, we're going to take 100% of what we have and subtract 5%. So what we're keeping is 95%. So our decay factor is 0.95. So what goes into the equation, if it's growth, is 1 plus the rate of growth. If it's decay, what goes into the equation is 1 minus the rate of decay. Now our exponential function is f of x equals a times b to the x. A is the initial starting value, and b is our growth or decay factor. So if it's growth, we're going to have f of x equals a times 1 plus the rate of growth to the x. If it's decay, we'll have 1 minus the rate of growth to the x. So here's a problem. The current population of Marietta is 115,000 and is growing 1.3% annually. Write a function to represent the population after x years. The a value is the initial amount, 115,000. We're growing, so we're going to have 1 plus the rate of growth. So 100% plus the 1.3%, or 1 plus 0.013. So f of x equals 115,000 times 1.013 to the x power. There's our function. Here's another problem. The amount of water in a glass is 500 milligrams and is evaporating 3% per hour. Write a function to represent the amount of water over time. Well, if it's evaporating, it's losing water, so that's decay. So we have 1 minus the rate of decay. 1 minus 0.03 is 0.97, and our initial amount is 500. So our function is f of x equals 500 times 0.97 to the x power. Now, another type of growth is compound interest. So we still have an exponential function. But now, that rate of growth for compound interest, we may take a piece of that rate during the year and give the person interest at that time. So we might have a yearly interest rate, but after a month, we're going to take 1/12 of that and give it to them at that point. And then next month, take 1/12 and continue like that. So our formula for compound interest is a equals p times 1 plus r to the n over n, or to the nt power. A is the amount of money that's in the account at any point in time. P is the principal, which is the initial amount that we invest. R is the interest rate. N represents the number of times we're compounding in a year. So if we're compounding every month, we would divide that interest rate by 12 and then do that 12 times a year for t years. T is the time, the number of years. So for example, you invest $4,000 in an account that pays 3% interest compounded quarterly. Find the amount in the account at the end of 5 years. Well, our principal, our initial amount, is 4,000. Our rate is 3%, or 0.03. Since we're compounding quarterly, that's 4 times a year. And then we're doing that for 5 years. So 4,000 times 1 plus 0.03 over 4 to the 4 times 5 power, or to the 20th power. So our initial amount, 4,000, our interest rate, 4 times a year. We're going to take a fourth of that rate and give the person the interest then, and then do that 4 times a year for 5 years. Now, when we calculate this, we don't want to do it in pieces and round off and then do the next part, because then our answer becomes inaccurate. We want to do the whole thing in one step on a calculator. So we can use parentheses, and we can divide, and we can take to a power, all in one step. So when we do this correctly, we get the value 4,644.736569. The question says, find the amount in the account. That's dollars and cents. So we have to round correctly to dollars and cents. So our answer is $4,644.74. So that's a quick review of 5.3. Now, 5.4 is geometric sequences. A geometric sequence is a set of numbers where we're multiplying or dividing by the same thing every time. So here's a sequence, 2, 6, 18, 54, 162. We can see that each time we're multiplying by 3. Now, if I take any number and divide it by the number that came before, like 6 divided by 2, that equals 3. 18 divided by 6 is 3, and so forth. When we compare two numbers by division, that's called a ratio. And so what we're multiplying by is called the common ratio. And that's what's going to go into equations. So we have two kinds of equations. The first is we're making a recursive equation, or a recursive formula. In a recursive formula, we have a sub n equals that common ratio times a sub n minus 1. Any term is the common ratio times the term that came before it. Now, in a recursive formula, we need a starting point, so we also have to identify the first term. So in our sequence above, the 2, 6, 18, the first term is 2, so we'll identify that. And then we said our common ratio is 3. So the recursive formula is a sub 1, the first term, equals 2. And then a sub n equals 3 times a sub n minus 1. Any term is 3 times the term that came before it. The next kind of formula is an explicit formula. An explicit formula says a sub n equals the first term times the common ratio to the n minus 1 power. That's what we usually use. Sometimes, however, we have a table or a word problem where we have a zero term. If we have a zero term, then our formula is a sub n equals that zero term times the common ratio to the n power. So our exponent has n minus whatever term we start with. So zero term, n minus 0 is just n. The first term, we have n minus 1. If for some strange reason we only had the second term, then we'd start with the second term and have n minus 2. So in our sequence, which was 2, 6, 18, 54, 162, the first term is 2, and we're multiplying by 3. So our explicit formula is a sub n equals 2 times 3 to the n minus 1 power. The first term times the common ratio to the n minus 1 power. Here's another sequence, 32, 8, 2, 1/2. You can see that for each, to go from term to term, we're dividing by 4. So what are we multiplying by? We're multiplying by 1/4. Remember, the common ratio, we take any term divided by the term that came before. 8 divided by 32 is 1 over 4. 2 divided by 8 is 1 over 4. So 1 over 4 is our common ratio. So our explicit formula, we have the first term times the common ratio. So a sub n equals 32 times 1/4 to the n minus 1 power. And there's our explicit formula. Finally, we want to be able to give an explicit formula if we have a recursive formula, and give a recursive formula if we have an explicit formula. So for example, write the recursive formula for the sequence represented by the explicit formula. So we're given this explicit formula, we want to write a recursive formula. Well, recursive formula says we need to identify the first term. Well, the first term is right there in the equation. It's 3. And then we have to have our common ratio. Well, our common ratio is 2/3. So our recursive formula is a sub 1 equals 3, and a sub n equals 2/3 times a sub n minus 1. And then we want to be able to go the other way. If we have a recursive formula, we want to be able to write the explicit formula. So the explicit formula starts with the first term. Well, we've identified the first term as 7, and then times the common ratio. The common ratio is what we're multiplying by. That's the 5. So the explicit formula would be a sub n equals 7 times 5 to the n minus 1 power. And so there's our quick review of 5354. Now you should be able to do the few problems that are assigned.